part of our lesson, we're going to take a look at bases and alkali. Alright, so they are at the other end of the spectrum. So acids, they have pH lower than 7. And bases and alkali, they have pH above 7. Okay, so like acids, alkalis are everywhere, right? Okay, so these are the learning objectives for bases and alkali. So the first one is, of course, to define what is an alkali. Okay, what are the ions they produce and how to test for them. Okay, the second one is the reaction between hydrogen ions and hydroxide ions. Okay, so hydrogen ions are produced by acids, and then hydroxide ions are produced by alkali. So hydrogen ions and hydroxide ions, they will form water. So this process has a name called neutralization. And of course, the next part is the reactions that alkalis can undergo. Okay, so let's move on. Okay, so what is a base? I would like you all to recall what you have learned in acids. So acids can react with bases to form a salt and water. So what is a base? Okay, a base is a metal oxides or metal hydroxide. So if you recall the previous lesson, we look at copper 2 oxide with sulfuric acid, and then you form the blue solution. Okay, recall. So this reaction will produce a salt, okay, which is an ionic compound, and water. There is no effervescent form, so which means that there is no gas produced in this reaction. So only water and salt are produced. So a base is any metal oxide or any metal hydroxide. So if you look at this, oxides mean it contains oxygen, okay? Hydroxide means it contains OH minus. Okay, all these hydroxide ions, can you please write it down? It contains OH minus. So we learn about bases, but then there is another term called alkali. So what is this alkali? So I would like you all to see as alkali is an opposite of acid. Okay, so they also dissolve in water. Okay, just that they produce a different kind of ions. Okay, in fact, they produce hydroxide ions. So alkali, they are soluble in water. So what state will they be? If they can dissolve in water, alkali, they are always in aqueous state. So from the previous slide, we learned about base. Okay, so base means any metal oxide or metal hydroxide. So bases can be insoluble, which means it does not dissolve in water, it remains as a solid, or it can also dissolve in water to form an aqueous solution. So this soluble base is called alkali. Okay, so alkali means soluble base. Okay, so bases have two categories. They can be soluble, they can be insoluble. Insoluble remains as solid. Okay, that means the solid doesn't dissolve. Soluble means the solid, when you add water, it will just form a solution. Okay, this part here not so important. Just know that alkali, they are soluble. Alkali, they are in aqueous state. Now, we have one special one. We have a special alkali called ammonia. Okay, now ammonia is a base. Okay, it is also an alkali. Now, based on what we learned, bases means you have oxide and hydroxide. Okay, but this ammonia is special. So that's why I put a star. This equation, you don't need to remember. Okay, it's for your information. To tell you why is it an alkali, because it can dissolve in water. Okay, so ammonia gas dissolve in water to form aqueous solution. And it also produces OH minus. So that is why ammonia is an alkali. Okay, it's a special base. Okay, so put a star here. Now, properties of alkali. So alkali, they are found in vegetables. Okay, in fact, these are the 7 most alkaline food. Right, you can highest content of alkali, so they are bitter and soapy feel. So I would like you all to go back home, or rather, if you're at home now, go and take a look at your soap, your shower gel. They should contain alkali. Okay, and because of this alkali, it creates this very soapy feeling. Now, similar to acid, they dissolve in water. Okay, for example, sodium hydroxide, metal hydroxide. Okay, it dissolves in water, aqueous state. So, aqueous state, what we learn under ionic, it means that they can separate into ions. Okay, so in aqueous state, they can separate That is why you have these hydroxide ions. Okay, these ions are mobile and they can act as mobile charge carriers. Okay, so this part here is under bonding. Recall. Okay, they are aqueous state, they can swim around, they can move freely, they can act as mobile charge carriers. So these ions can conduct electricity. Alkalis, they have pH more than 7. They can turn moist red litmus paper blue. Okay, so we are using moist litmus paper because we want to have the water, okay, to allow it to dissolve to form your hydroxide ions. Okay, take note, it is moist red litmus paper turns blue. Okay, acid is blue to red. Alkali is red to blue. Okay, just remember one will do. Acid is red color. Then of course alkali will be the opposite. Now before we move on to the next slide, let me warn you, the next slide contains some disturbing graphic photos. So if you're not comfortable, then you just maybe close your eyes or just squint a little. Right, let's take a look. Okay, you all know what are these? What happened to these people? Okay, so I'm not sure whether some of you have seen it before or have experienced it yourself before. I hope not. Okay, these are the stings from the jellyfish. Okay, so you can see the tentacles here. Alright. And of course some of the wounds that is caused by the venom. Right, so not sure whether you have heard of this myth before. Some people actually urinate or pour vinegar onto these wounds to make it less painful or to cure it. Okay, and they work on this principle called acid-base reaction. Okay, so the sting of some jellyfishes contains alkaline venom. Okay, and the pain from the sting can be eased by applying vinegar. So it will make more comfortable by applying vinegar on these wounds. Okay, so disclaimer, this is only to treat some alkaline jellyfish venom. Okay, not to ask you to do it. Okay, best is to seek medical professional advice. Okay, so it does help to release some of the alkaline jellyfish venom because acid in the vinegar can neutralize these alkaline jellyfish venom. So this is how chemistry comes to play. So recall, under acids, okay, alkali, they are soluble bases. I repeat, alkali are soluble bases. So they can react with acid to form salt and water. So this is a reaction that we have covered under acids. How to come up with the ionic equation, please go and refer back to the previous video. Okay, so aqueous, I can split them into their individual ions. Okay, I will cancel out Na+, here. I will cancel out Cl-, Cl-. H2O liquid, I will copy and paste into my ionic equation because only aqueous state I can split them into individual ions. Okay, and then I will get this. If you realize, OH- is from the alkali, H+ is from the acid, and then my water is formed. Okay, so this is what we call neutralization reaction. Okay, this is the ionic equation for all acids and alkaline. I repeat, this is the ionic equation for all acids and alkaline. Okay, so acid is your H+ ions, OH- is your hydroxide ions from the alkaline, and then they will produce the water. Okay, so this is the first reaction. The next reaction, something new. Okay, alkali, they can react with ammonium salts. Okay, so alkali can react with ammonium salts to form these three products. When you see ammonium, okay, I want you all to recall what is ammonium salt. What must it contain? Okay, under ionic compound, we recall the formula. Ammonium salt contains NH4+. Okay, so this ammonium ion can produce your ammonia gas, which is NH3. So this ammonia comes from ammonium. Note the difference. One is a cation, one is a neutral molecule. Okay, so alkali can react with ammonium salt to have these three products. This reaction must be heated. Okay, so if you take a look, an example, I have my sodium hydroxide, likewise metal hydroxide, alkali, aqueous. I react, for example, with ammonium chloride. Okay, so ammonium chloride, the formula is NH4+, Cl-. Okay, and then they will react to form sodium chloride, water, and ammonia. Now, if you don't know how to form this reaction, okay, at least remember this. Okay, there is NH3 form. Okay, so NH3, 3 hydrogen, right? But here has 4 hydrogen, right? So one of this hydrogen together with this OH. One of this hydrogen together with the OH, okay, you will form water. Okay, whatever remain, okay, which is your Cl minus and Na plus, they will form your salts here. Same thing, those they are in aqueous state, I can split them up. Okay, so those that are in aqueous state, I can split them up. For example, this Cl minus and Cl minus will be cancelled out. This Na plus and this Na plus will be cancelled out. Liquid state, gaseous state, I cannot separate them. I will copy and paste into my ionic equation. Okay, so this NH4 plus cannot be cancelled out, right? Because it's different from NH3. They are two different things. This OH minus also cannot cancel out. So I copy and paste whatever that is not cancelled out into my ionic equation. Okay, so this is my ionic equation. If you count the number of atoms from both sides, they will tally. So how to test for ammonia gas? Just now, what did we mention about ammonia? It is a special type of base. Okay, so it's an alkali. So to test for alkali, we use moist, red or blue. Okay, we use moist red litmus paper to test for it. Okay, so if alkali gas is present, if ammonia gas is present, moist red litmus paper will turn blue. Okay, I need the water, okay, to turn this ammonia gas into aqueous state. So this reaction will produce ammonia gas when it is being warmed. Okay, so that is the last reaction of alkali. Let's recap what we have learned so far. Okay, so first of all, we learned to define what is an alkali. So I want you to pause the video to recall what is an alkali. Okay, an alkali can dissolve in water. They are soluble bases. They dissolve in water to form aqueous solution to produce OH minus ions. Okay, so they are tested using moist red litmus paper and then they will turn blue. Okay, so later on we'll take a look at what is their effect on universal indicator. Okay, so that's the first learning objective. Okay, then we take a look at acid plus alkali. Okay, so acid produces H plus, alkali produces OH minus. Together, they neutralize each other. Okay, they neutralize each other to form water. Okay, then the next reaction that we have learned will be alkali can react with ammonium salt. Okay, alkali can react with ammonium salt to form salt, water, and ammonia gas. Okay, so this is the end for alkali. Okay, moving on to the next one. Just now we mentioned about universal indicator. Okay, let's take a look at something very colorful. Okay, we talk about pH 7, below pH 7, and above pH 7. So what exactly is this pH scale? Okay, so we're going to take a look at the effects of acids and alkali on this universal indicator. Okay, and what do we know about this pH scale? What does it mean when we say below pH 7, above pH 7? Okay, and after learning acids and alkali, what are some of the real-world applications of that? So pH scale is to tell us whether a solution is acidic, neutral, or alkaline. So it's like a ruler. A ruler tells you how long or how short a substance is. Okay, so it's the same. So this pH scale tells you how much H plus ions, okay, your acids, or how much hydroxide ions are present in the solution. Okay, for example, the water that we drink, tap water, we are curious what is the pH. We use this pH scale, okay, to find out what is the concentration. Then pH scale is a set of numbers. Okay, it is a range from 0 to 14. Okay, it tells you whether a solution is acidic, alkali, or neutral. Okay, so it's just a scale to tell you whether something is acidic, neutral, or alkali. Okay, so this is the universal indicator and their colors. So from 0 to 14. 0 is very red. Okay, so I recall saying that when you talk about acid, okay, they turn solution, they turn indicators red. Okay, blue litmus paper turns red. Okay, and then of course on the other side of the spectrum, we have alkali, okay, where it's blue and purplish. Okay, so at pH 14, it means very, very, very alkaline. Okay, and then in the center, okay, in between 0 to 14, the middle number, which is 7, it is neutral. Okay, so this pH scale tells you about OH minus and H plus. when something is very acidic, okay, so below 7, we call it acidic. Okay, when something is acidic, acid produces H plus. So we will say that there are more H plus than OH minus. Okay, when it's neutral, we say that the H plus and OH minus, they are equal. Now this square bracket, you don't need to care. Okay, it just tells you that this square means the amount of H plus. Okay, whereas in alkali means there are a lot of OH minus, more than H plus. So take a look at this scale again and try to understand why different solution will have different pH. Neutral means there's a balance, okay, H plus and OH minus. So your water, distilled water is 7, is H plus and OH minus, they are equal. Okay, so what do I mean by this? Your water, okay, don't need to memorize this. Just be aware that water produces H plus and OH minus. Okay, even though I recall saying that liquid does not separate, right? But actually a small amount, a very small amount will separate. Okay, so don't need to remember. Okay, just take note that water is equal amount of H plus, equal amount of OH minus. When they are equal, it means pH 7. Okay? So let's take a look. When it's in acidic solution, acidic means, for example, I have HCl. So I have HCl, you can see that Cl minus, H plus. Okay, acid dissociate to form H plus ions. So if you count, I have 1, 2, 3, 4, 5. 5 H plus from the acid. And then I have 6, 7, 8. This green color represents the one from the water. So I have a total of 8 H plus. Okay. OH minus comes from the water as well. 1, 2, 3. Okay. So 8 H plus versus 3 OH minus. I have more H plus. More H plus means acidic. Okay. For alkaline will be the opposite. So just take a look at this diagram. I have more OH minus, which is the one in blue color, as compared to H plus. Okay. And this is the scale. And then you can take a look at how different items here, they have different pH. So lemon juice, okay, sour lemon juice, sour orange juice, they are all having low pH, acidic. Okay, vinegar, also sour taste, okay, is acidic. In fact, your Coke, your fizzy drink, okay, they are also slightly acidic. Okay, and then pure water is 7. Your blood is slightly alkaline. Not sure whether you have tasted your own blood before when your tooth drop out. Okay, you taste a bit of metallic and a bit bitter. And that is because it is slightly alkaline. Then how do we measure pH? Okay, your universal indicator only tells you the rough gauge. Okay, another way is to use data logger or rather a sensor to sense the pH. So they are connected to the computer. They will tell you the value of the solution, the pH value of the solution. Okay, so indicators, they have different colors. Okay, just now we saw already. And some of the common ones will be your litmus. When it's acidic, okay, your blue litmus paper will turn red. When it's alkaline, it will turn from red color to blue color. Okay, so pH where it changes color is 7. And then we have other common ones like metal orange. Now you don't need to memorize these indicators. You don't need to memorize the colors. You don't need to memorize the pH range. It's just for you to be aware that they are pH indicators. Question can give you an example and ask you to deduce the color. Okay, so let's try. So for example, okay, I have a solution that is maybe pH 2. Okay, and then I use metal orange. So my unknown solution is pH 2. Metal orange, below 3, it is red. Okay, when it's above 5, it is yellow. Okay, when my unknown is pH 2, the indicator will become red color. Okay, to tell me that it is acidic. Now, if I have a solution that is maybe pH 7 and I use, for example, screen metal orange, okay, what will the indicator show? What color will it be? Because it's pH 7, okay, it changes color during this range. Below 3 is violet. Above 5, it will be green. So what color will pH 7 solution show? It will turn green. Okay, so these are some of the questions that they can ask you regarding indicator. But they will give you this table. Okay, they will give you this table. Okay, so table will be given. You don't need to memorize. Okay, moving on. So we have different kind of indicator. Universal indicator means it has more colors and it changes at more pH levels. Okay, so this is another one, pH meter, data logger. It will give you a better and more accurate pH values. So pH levels, they are important. You cannot vary too much, especially for example, your blood pH level. Okay, if you have very low pH, for example, 7.2, 7.1, it is considered acidic to your body. Okay, and then you will suffer from acidosis and it can even lead to death. Likewise, in the opposite direction, normal pH is 7.35 to 7.45. If it's, for example, 7.6, it's considered alkaline. So you will suffer from alkalosis or even death. Okay, so it's important to manage the pH level. Not just your body, even for plants, they require healthy growth. Okay, so you can see from here, okay, the soil, there is a pH value. Okay, it is affected by whatever you add into the soil. Okay, so how to control if it's too acidic? Okay, so just now you learned, right? If it's too acidic, you want to neutralize. You neutralize with base. So when you neutralize with base, only salt and water are produced. Okay, so these are the two bases. Please fill in the blanks in your notes. Okay, so we have calcium oxide, metal oxide, or we have a calcium hydroxide, which is also a base, metal hydroxide. We also write down another name for slick lime is lime water. So some of the questions can use the term quick lime, slick lime. So this one, please remember. How to remember? Okay, I will see as CAO. So quick, I will remember it as tao. It sounds similar to our dialect word tao, tao, tao. So I will remember it as quick, quick, quick. Okay, like quickly go. Okay, so I'll remember it as calcium oxide, quick lime. Okay, slick lime, it will be your lime water. Okay, the one you use to test for carbon dioxide. So this process is called liming because if you notice the name, okay, they all have this word called lime. Okay, calcium carbonate, okay, is your limestone. Write this down inside your notes. Okay, you can also add limestone to it. Another name for limestone is called marble. Okay, but in chemistry, we use the chemical name which is limestone. Okay, so the bases will react with the acids in the soil and they will neutralize, okay, and increase the pH. So you can write down here neutralization. Because the soil is acidic, okay, pH will be below 7. When you add these bases, you neutralize the acid, they'll become neutral, and pH will increase. So what are the things that we have learned so far? The effects of acids and alkalis on universal indicator. So what color will it produce for acids with universal indicator? Okay, the answer is red. What about alkaline? What's the color when you have alkaline solution? Okay, universal indicator will turn blue, okay, or purple. Usually it's purple, okay, for universal indicator. So put a tick. Then the second one, we take a look at how to test for hydrogen ions concentration using pH scale. Okay, so if we have more hydrogen ions compared to OH minus, pH will be below 7. Okay, if we have H plus equal to HH minus, pH will be 7. If we have H plus below OH minus, that means I have a lot more OH minus alkaline solution, pH will be above 7. So this is the scale. You can see how the different pH, different colors for the universal indicator, and what do they mean. Okay, so if you understand this, put a tick in your notes. Okay, and the last learning objective will be, what is the real world application of learning all these? Okay, one of them will be to control the pH in soil. Okay, because the pH in soil can be affected by fertilizers. Okay, this can cause the soil to become acidic. Alright, so to adjust the pH, okay, we can add base such as calcium hydroxide, okay, calcium oxide to neutralize it or to increase the pH. Okay, so if the soil is too acidic, recall what are the two things to add. Okay, the process is called liming. So we're going to add something that contains this word called lime. Okay, so the first one will be quick lime, calcium oxide, which is a metal oxide. The second one, we can add slick lime, calcium hydroxide. So these two are bases. Okay, bases means metal oxide or metal hydroxide. Okay, so this is the last learning objective for this section here. Okay, now we're going to move on to the last part of our lesson, which is the types of oxides. We have seen one of the types previously. You all know what is it? Just now we talk about it. Metal oxide. Okay, metal oxide is a base. So we have seen that. Okay, there are also other types of oxides such as non-metal oxides. Okay, so we will take a look at that. So the learning objective for this is that we're going to identify the different types of oxides. Okay, we have metallic and non-metallic, and different types will have different character. So the first one is acidic oxide. So if you take a look at the name, acidic oxide means that it has acidic property. Okay, so we learned about base just now, right? Base is metal oxide. So alkali is sort of like opposite of acid. So now we have acidic oxide. Base is metal oxide. Acidic oxide will be non-metallic oxide. Okay, so some of the examples are here. Do you need to memorize all these? Need to understand. Okay, or rather need to understand that non-metallic oxide will be acidic oxide. Okay, so some examples will be sulfur dioxide, sulfur trioxide, carbon dioxide. Okay, I want you all to take note. Acidic oxide, right? They are non-metallic oxide and they all contain oxygen. And if you notice the number here, they contain more than one oxygen. They contain more than one oxygen. So they are non-metallic oxide. This is non-metal. Okay, write down inside your notes, non-metal. Oxygen is also non-metal. So non-metal and non-metal, what kind of bonding do they have? Recall, non-metal, non-metal, what kind of bonding do they have? They are all covalent molecules. Okay, they are all covalent molecules. So they are covalent molecules. They have low melting point and boiling point. Okay, so that is why they exist as gases. They dissolve in water to form acids. Okay, so recall, acids, they can dissolve in water to form aqueous state, and they dissolve in water to produce H plus ions. Okay, so since they're acidic oxide, acids, so they behave like acids. So they can react with alkali to form salt and water. So take note, non-metallic oxides, they are acidic oxides. Okay, they contain more than one oxygen atom. Now, if you cannot remember, okay, I want you all to recall, for example, carbon dioxide. Now, you breathe out carbon dioxide. Okay, you recall, especially in the morning when you just woke up, you'll be like, oh, your mouth is very dry, and then your breath doesn't smell very fresh. That's why you need to brush teeth. Okay, so the reason why your breath in the morning smells a little bit sour and it might stink a little because of the accumulation of all these carbon dioxide gas in your mouth, and it stimulates bacterial growth. Okay, so carbon dioxide, the air they breathe out is acidic. So it's acidic, and that is why you need to brush your teeth using toothpaste, which is alkaline. Okay, so remember the gas that you breathe out, carbon dioxide gas is acidic. And so this is your acidic oxide. Okay, then of course this one is something that we have learned. Okay, metal oxide, they are solid at room temperature. They react with acid to form salt and water. Okay, I want you to write it down inside your notes. Another name for this is called bases. Okay, metallic oxide. Now, why are they solid at room temperature? Because I want you to write inside your notes. This is metal and this is non-metal. Okay, so metal and non-metal, they are ionic compound. And if you recall, ionic compound, they have high melting point and boiling point because of their strong electrostatic forces of attraction between opposite ions. Okay, they can be soluble, they can also be insoluble. Okay, I want you all to cancel out this one inside your notes, change it to K, there is a typo here, so it should be potassium hydroxide. Then this one, just cancel it out, okay, to make things easier for you. Okay, what do I mean by to make things easier for you? If you take a look at this one, alright, this is group 1. Okay, so all group 1, okay, salts are soluble. All group 1, oxides are soluble. Okay, so write down inside your notes, group 1. Okay, they are soluble. Group 1 compounds are soluble. Okay, and then group 2 or other metal oxides, they are insoluble. All of them are insoluble. Okay, so only group 1 compounds are soluble. So moving on. Now, there are some oxides, some metallic oxides, okay, they are quite special. They are exception. Okay, so if you take a look at previous slide, we talk about metallic oxides, they are basic oxide. Okay, and they react with acids. Okay, however, there are some metallic oxide. Okay, metallic oxide, metal oxides, they are the same thing. Okay, for example, these three. If they are metal oxides, so by right, they fall under the category of base. Okay, so they react with acids. But then, okay, they also can react with alkali. So they don't just react with acids, they can also react with alkali. Okay, so we call them amphoteric oxides. Okay, and there are only three of them. And how to remember? I remember it as ZAP, Z. Okay, so zinc oxide, aluminum oxide, lead-2 oxides. Okay, they are metal oxide. They are not just basic oxide, they are also acidic oxide. Okay, so they are amphoteric oxide. Okay, take note of the spelling. So these are the reactions. Do you need to remember? Don't need. Okay, don't remember. But I want you all to take note. Okay, you need to take note of this. When they tell you this oxide reacts with acid, it also reacts with alkali. So at this stage, you need to be aware, oh, can react with acid, can also react with alkali. Okay, so these types of oxides, they are called amphoteric oxide. Okay, so amphoteric oxides react with acids and alkali. They will form salt and water. However, the salt, if you notice from here, there are different kinds of salts. Do you need to remember? Don't need. Okay, so you just need to know that they react with both acids and alkali to form salt and water. Okay, and then there are some kind of oxides that will not react with both acids and alkali. They're just neutral. They just don't react. Okay, so we call them neutral oxides. Okay, and they are non-metallic oxides. So if you see hydrogen, nitrogen, carbon, they are non-metallic oxides. And I want you to take note. How many oxygen atoms are there? Do you notice that neutral oxide, they are non-metallic and they only have one oxygen? Okay, so my water, my nitrogen monoxide, my carbon monoxide, they are neutral. Okay, so they don't react at all. Okay, they don't react with acids, they don't react with base. Okay, the second point is just for your information. Okay, so this part is FYI. Okay, so please take note, neutral oxides, okay, they are non-metallic, they only contain one oxygen. Carbon monoxide, take note, this is a common mistake. Carbon monoxide is toxic, which means it will lead to death in human beings. But it does not mean that it will react with acid or alkaline. They are toxic, okay, but toxicity and whether or not it can react with acids or alkali, they are two different things. Okay, so don't confuse yourself. Just know that they are neutral. Okay? Okay, so they are all monoxide. They only contain one oxygen atom. And yes, we are finally done. Okay, so good job for completing acids and bases. Okay, recap. Classify oxides as acidic, basic, and amphoteric. So, for example, I give you one oxide. Okay, you need to identify whether it is acidic, basic, amphoteric, or neutral. So the first one, acidic oxide, recall. What kind of oxides? Metal or non-metal? You must ask yourself, what are the examples first? Okay, so if you recall, CO2. CO2 is non-metallic oxide, okay, and they can react with alkali. So the gas that you breathe out is carbon dioxide is acidic. Then of course, the opposite of acidic oxide, the opposite is basic oxide. Okay, and another name for it is base. They are metal oxides. They react with acids to form salt and water only. Okay, and then we have a special group of oxides. Okay, they are special because they can react with both acids and alkali. Okay, so we call them amphoteric and they are Z. Okay, ZAP. Write down zinc oxide, aluminum oxide, and the last one, the P, is lead-2 oxide. Okay, and the last group of oxide is the group that does not react with anything. Does not react with acids, does not react with alkali. They are neutral oxides. They are non-metallic. They do not react with acids and alkali. Okay, so some examples will be CO, NO, H2O. So if you notice, they only contain one oxygen atom. So they are monoxide. Alright, so this is the end of oxide. Any question, please let me know.